All right, in this lesson, we will talk about generics with Java. So generics allow us to create parameterized data types, right? So this is best explained with an example, and a very common one is the Java class ArrayList. ArrayList is a generic, and it is used to create resizable arrays, right? So more specifically, ArrayList is written like this: ArrayList with angle brackets with the letter E in the middle, right? So ArrayList is the generic class, and E is the generic type. So what does that mean? Now, this is the type of each element of ArrayList. So E will need to be replaced with what's called a concrete type, which would be something like a string or a double to actually create the ArrayList class. Okay, so we can explore this a little bit more by looking at some code. This is the example of creating an array list of string elements. So you would write array list with string within the angle brackets, followed by the identifier, followed by equal to the new operator, and then array list in this form. Notice that there is no data type provided here. Right. Similarly, you can use code like this to create an array list of doubles. Again, no data type that is provided here. So let's actually try this out in code. We will open up IntelliJ, and here we have a skeletal program, and as I mentioned, you can create an array list with angle brackets. Notice when I did that, what happened is it imported it from Java util. That's where you'll find array list. Now within the angle brackets, we'll have our type, which we'll use string, and then we'll have the identifier. We'll use the same one as in the lesson, right, student names, and now we have to create it. So we will use the new operator followed by the array list constructor. Again, notice no data type is being provided here. So this will create a resizable array holding elements of type string. Now, what can you do with it? ArrayList provides a bunch of interesting methods, so let's use them to add things to this array list. So you have student names, and there's something called add, and let's add Jane Doe as one student, right? And then we'll add another one. Let's say John Doe for the next student, and now let's. We want to print this, so we will system out print line. And then how do you print this? So you would, one easy way to do it, if you remember toString from other lessons, that is a good way to, you convert it to strings and then you can print it. So let's see what it looks like when you do this. So you do that and it gives us a nice representation of the array, right? We added Jane Doe first, then we added John Doe. All right, so let's move on. So what is the benefit of this? I mean, could we have achieved the same goals through other means? And indeed, before JDK 1.5, there used to be an approach using object superclass and polymorphism that we have covered in other lessons to get the same effect. The problem was that with this approach, you were very liable to run into runtime errors. Since some of this type checking wasn't really being done by the compiler, if you happen to be using the wrong type, and while you were expecting a different type, you would have issues during runtime. So generics allow you to define classes and methods using generic types, and they are checked and replaced with concrete types during compilation. So any errors are caught during compilation, and that's the big benefit, right? So we went through this example where we added an element to student names. Now and this was perfectly fine now, but if you try to add something that is not a string, suppose you try to add a double, you will get a compiler error, or your IDE will point it out. So that is being the benefit of this. So actually, let's go back to the IDE and actually see what happens. And here, if I say 1.0, it will, the IDE will point it out with a little red mark, but also if you try to run it, you will get incompatible type. So this will be caught at compile time, not something you will discover at runtime. So that's the big benefit, right? Now the generic type that you use with your generic class can't be a primitive type. So for example, it cannot be something like an int or a boolean or a char. So in this particular example, an array list, you cannot declare it with an int, right? Instead, you must use the integer wrapper class, right? So each of these primitive types have a wrapper class with capital integer or capital boolean or capital double are available to you, right? So the right way to do this is to declare it in this way with the integer wrapper class, right? And once you've done that, then you can add something like a 7 to this integer array list, and Java will automatically convert the 7 into the corresponding wrapper class that you used to declare your array list, right? So let's actually try this out. Let's go back to our code. We'll get rid of this offending line, and then let's just try to declare something with a primitive type. So instead of student names, we will call it student scores, right? And instead of a string, we will use double. And you'll notice that it does not like it. And if you compile it, you'll get an error. However, if you use double, this will be just fine, right? And then you can use it to add things. So you can say student scores and then add 94.5 or something. And that is perfectly fine. Okay. So the other thing we should mention is that the compiler will do a lot of casting for you already. So let's look at that with a couple of examples. So here we have the same thing. We have defined so far student names. We've added Jane Doe and John Doe. Now, if we were to retrieve a value, so in this case, the method get and the index 0 is being used to retrieve the first element from the array list, which will be Jane Doe, and then it'll be extracted and then it'll be assigned to string. There's no casting needed. The compiler will knows the type and will do that for you. Similarly, the student scores that we just defined and we just did and adding a couple of added a number. Even though this is a literal, it's an actual value, it is auto-converted into a double like this for you. Similarly for the second one. And then when you are extracting it and getting it, there's no casting need here. And also if you were extracting it and setting it to a primitive type, there is no casting needed. It is auto-converted for you. So these are the kind of conveniences that you get, right? So actually this is the first time you're using get, so let's just take a look at what that would look like. Actually, we will take this code and we will just use that. So we'll open up IntelliJ, and then let's do this. And we might want to do a few things. We might want to actually print our array. So right at the end, we will print student scores. Right. And we might comment this out just so we don't get any extra noise. We've added 3 scores here. We've gotten the first one. Then we're getting the the second one, we're printing the whole array. And then another thing we might want to print are the other two values. So we want to put dobj, which is the object double, which is the wrapper class, and then the actual primitive type, right? So let's see what happens. Which you should print the whole array with these three values. Then you should put 94.5 for the first one, and then 90.0 for the second one. So that's exactly kind of what it does. Okay. So we've been using a couple of methods from ArrayList. So let's take some time and look at what else is available to us, what other methods are available to us. This is not a comprehensive list, but are some of the more interesting ones. So let's take a look. There is get with an index parameter that's passed in that basically gets an element at that index. There is set with an index and object provided that updates an element at that index. There's a size. There is adding, which we have used, providing an object and add it to the end of the array list. There's add at a particular index. We'll actually try out this add and set and see exactly what happens. What happens to the element that was there? Do they get moved over? Do they get replaced? So let's do that. This removing an item at an index. There's also removing an object. And then there's clear for kind of clearing out the array. So let's try out set and add and see what the behavior is. So we'll open up IntelliJ, clean out a few things that we don't need. So what will be left is an array of 3 elements, and then we'll use set and add. So we'll print the array as it exists with the 3 elements, and then let's just first use set. So if we use, let's say, student scores, and we say set, let's just set it at index 1, and we'll make that a bad score of a 0. And then we will print what it's not like. It doesn't like 0 being, thinks it's an integer. So let's see what happens with set. So if we do set like this, it doesn't change anything. It still it still has 3 elements. It does change the value here, right? Now if we were to do add at 1 location, let's see what happens then. So here it added that location and moved everything to the right. So that's the difference between set and add. And you can try this out with other things you might be confused about. So let's talk about what it would take to create generic classes ourselves, right? So for this, we'll use a particular data structure called a stack. It is a last in, first out data structure, and it's pretty much what it sounds like. Imagine having a stack of books. You add to the stack by putting things, books on top of the stack, and when you remove things or you look at the stack, you're always looking at the last thing that was, or removing the last thing that was added. So it's a last thing that you add in is the first thing that you remove, to be distinguished from a queue, which is a first in, first out data structure. Right. So we will define a class called generic stack that implements the semantics of a stack data structure. Right. It is generic because the stack can hold items of any data type, and we'll use a generic type actually to achieve this. So you would define a generic stack as such, generic stack, and in angle brackets you would use the letter E as the generic type. Inside we use a private member variable, which is of type ArrayList, using the same generic type E, to create a resizable array that we'll use to store these elements. And the methods that we'll provide is to get the size of the stack, look at the first element, look at the top of the stack, put something in the stack and push something onto the stack, and remove something or pop something from the stack. So that's how it is implemented. Again, the important thing to look at is how we specify the generic type, right? Okay, so we're using the letter E. You might also find the letter T used to represent the generic type. Now, it doesn't matter which one you use. It is basically a placeholder, right? If you were showing this in UML, you would show it like this, with the E in the angle brackets right in the name, and using it wherever you happen to be using your generic type, right? The other thing to note is this E is a placeholder anywhere that the generic type would be needed. So if you're pushing something onto the stack, it is used for the data type of an element in the stack. If you are removing something, it is the data type for when it is removed, right? So this E will show up in the place of the data type of an element in the stack, right? Same thing here in the UML description, right? So, and then if you're using it, you're using it pretty much as you would expect. You would define a generic stack with the generic type of string. If this one happens to be a stack of type string, you would create it with the new operator, and then you would use a push to add things onto it, right? Since it is a generic type of stack, you can also have a stack of integers, and here you're putting integers onto the stack. Now, although it is of type integer, you can put a literal here, and it gets auto-converted using the example that we showed earlier. So actually, let's use this a little bit before we go further. So let's copy this definition, right? And let's try to use it in code. So what we will do is open up IntelliJ, and since this is a new class, we will put it right at the top, right? Now, what it's complaining about is ArrayList here, so we just need that definition. So we'll just add an import for that here, and then everything is okay. All right, so now we have the definition, although we're not really using it. So let's go back and copy the code for creating it, and try to use that. Now you created the stack and you put some things on. However, you still have an issue where you have no way of seeing the contents of the stack. So what you might want to do is you might want to print the contents of the stack. So let's add another method for that. And we'll call it public. And this is just void. Because we're just printing it, right? And the easiest way to do this might be to just use toString, right? So you have your stack, which is a list, and then we have toString, and that should be good enough. So, and then if you go here and you say s1 print, that should print the stack. So let's actually run this and see what happens. Yeah, so it prints the stack, right? And then you can pop and push and use all the methods that you would need. You can similarly create a stack of integer. So let's copy that and do the same thing. And similarly, we'll print the S2. Sorry, not S3. And take a look at this, right? So you've got a stack of strings, and you've got a stack of integers, all using the same class definition. That is the power of generics, right? Now, as I said before, there are ways to achieve this without actually using generics. You could have a stack of object, which is the superclass type. But what you'd lose there are the compile time checks you get. For example, if you had the stack of strings and you try to put a number on it, you will get a compile time error. So actually, let's actually try that out. We'll just copy that into our code and see what happens, right? So if we go the way to the bottom and then we did this, the IDE is already complaining about it, but you will see the same thing there, incompatible types, right? So it's giving you the compile time checking, right? Okay, now the concept of generics can be extended to interfaces as well. A very common generic interface is something called comparable. You might remember clonable, which is an interface that makes you have a clone method. This is a comparable interface, which allows you to compare two objects, right? Comparable is a generic interface. It is defined as so. It has a generic type here that is used also in the method compare to, right? So compare to method, compares an object to another object, right? And the compare to method returns a negative number if the object is less than if the object itself is less than the object passed in. It returns 0 if they're equal, and positive if it's greater than. So it's a convention, right? So the generic type E will be replaced by a concrete type when you're actually implementing the interface. There are many Java objects that give you this or implement this interface. For example, integer, double, all these will do that, right? But you can define your own by implementing that interface and providing a definition of compare to. You can compare two dates, right? You can imagine comparing two circle objects, right? By implementing the interface and providing that implementation for that method, right? Okay, now the interesting thing you get by doing this, if you do implement the comparable interface, it gives you the ability to sort those type of objects by using Java util array sort and by passing it in, right? Because the sort function uses the compare to do the actual sorting, right? Okay. That is what I'd like you to know about generic interfaces, right? Apart from having generic classes or generic interfaces, you can define generic methods without needing a class, right? So a generic type can be defined for a static method. It's a method that not necessarily belonging to any class, right? So here I'm going to give an example of a generic method to print a stack. So this is a main class with a main method here. Now I'm not using my generic stack that I showed earlier. I'm just using an array to represent a stack, right? And here is an array of integers and here is an array of strings. And I am using a generic method called showStack to print them, right? Notice that I'm using the same method to print, to take in an array of integers or an array of strings. Now, how can I do that? I can do that because this method itself is a generic. It uses a generic type, right? So the way you define is interesting. You need to put E in angle brackets right in the after the keyword static. That is a requirement. And then you use E as your as needed within the body and within the parameter list, right? So then you're just printing it as normal. So that is how you would define a generic method, which is a static method. Okay. Now you can call just show stacks like this, or if you want it to be more accurate, you can call it in its full form, but that is not really necessary. The compiler knows how to convert it into this. Okay, so that's been an introduction to generics with Java. Thank you.